September 7th, 1944. The morning fog hung thick over the cobblestone streets of Nancy, France, clinging to the burned-out buildings like a shroud. Technical Sergeant David Kellerman stood in the courtyard of what had once been a metalworks factory, now reduced to twisted beams and scorched brick. Around him lay the carcasses of 4 M4 Sherman tanks, their hulls blackened, their turrets blown open like tin cans under a hammer. He knelt beside the closest one, running his gloved hand along a puncture wound in the side armour. The hole was clean, almost surgical, no wider than a man's fist on the outside, but inside the crew compartment the damage was catastrophic. Molten metal had sprayed across the interior, flash-burning everything it touched. The smell of burnt rubber and flesh still lingered despite 3 days of rain, muttered Lieutenant Collins, standing behind him with a clipboard. 4th Platoon lost all 4 tanks in under 10 minutes. The founding dome. Krauts hit them from windows, alleys, rooftops. Crews didn't stand a chance. Kellerman didn't respond. He was staring at the entry wound, measuring its angle with his eyes, calculating the trajectory. The German Panzerfaust was brutally simple, a disposable tube that fired a shaped charge warhead. It cost almost nothing to manufacture, required no training to use, and could penetrate 5 inches of hardened steel. Against the Sherman's side armour, which was barely 2 inches thick in places, it was devastating. What troubled Kellerman most was not the weapon itself, but the mathematics of the problem. Every Sherman destroyed meant 5 men dead or maimed. The Third Army alone had lost over 200 tanks in the past month, most of them to handheld anti-tank weapons fired at close range during urban fighting. The crews called it the lottery. You rolled into a French or German town, and somewhere in the rubble, a teenager with a Panzerfaust was waiting to turn your tank into a coffin. Kellerman stood slowly, his knees aching from the cold. He was 32 years old, a mechanical engineer from Toledo, Ohio, who had spent the years before the war designing conveyor systems for automobile factories. The Army had assigned him to the Ordnance Department's Field Maintenance Division, a job that meant he spent most of his time welding broken tracks and patching holes that shouldn't have existed in the first place. But this morning, staring at the wreckage, he felt something shift inside him. A quiet anger, precise and focused, the kind that comes not from helplessness, but from seeing a problem that could be solved. "Sir," he said, turning to the lieutenant, "what if we could stop the warhead before it reached the hull?" Collins looked at him with tired eyes. "That's what the armour is supposed to do, Sergeant." "No," Kellerman said. "I mean before it touches the armour. What if we could detonate it early, in open air, where the jet can't focus?" "The," Lieutenant frowned, "you're talking about standoff protection. The engineers in Detroit have been working on that for months. Too heavy, too complex. They can't make it work in the field." Kellerman nodded slowly. The official solution involved welding thick steel plates at angles around the tank's hull, creating a cage that would trigger the warhead prematurely. In theory, it worked. In practice, each cage added over a ton of weight, slowed the tank to a crawl, and required a week of machining in a rear area depot. By the time a tank was fitted, the war had moved on. "What if it didn't have to be steel?" Kellerman said quietly. Collins tilted his head. "What do you mean? What if it was just wire, mesh? Something light enough to weld on in a day, cheap enough to make from scrap?" The lieutenant stared at him for a long moment, then shook his head. "Wire won't stop a shaped charge, Sergeant. It'll go right through." "It doesn't have to stop it," Kellerman said. "It just has to touch it." That afternoon, Kellerman returned to the makeshift repair depot on the outskirts of Nancy. The facility was little more than a muddy field lined with damaged tanks waiting for parts, surrounded by canvas tents and a few corrugated steel sheds. Inside one of the sheds, a welding crew was patching a hole in a Sherman's transmission housing, sparks flying in bright arcs across the dim interior. Kellerman found the supply sergeant, a grizzled man named Kowalski, who had a reputation for scrounging anything that wasn't nailed down. "I need wire," Kellerman said. "Lots of it," Steel, thick gauge, whatever you can find. Experiment. That's not an answer, Sarge. It's the only one I've got right now. Kowalski studied him for a moment, then shrugged. There's a bombed-out rail yard about 2 clicks east. Germans left behind some freight cars full of construction material. Might be some rebar, cable, who knows. You want it, you haul it. Kellerman nodded. I'll take a deuce and a half and 2 men. By evening, they'd returned with a truck bed full of wire. Most of it was rusty, bent, salvaged from fences and demolished buildings, but it would do. Kellerman spent the next 2 hours sorting it by thickness, laying out coils across the floor of the shed like a metal spider web. The mechanics watched him with a mixture of curiosity and skepticism. One of them, a corporal named Eddie Briggs, finally spoke up. You planning to knit the Krauts a sweater, Sarge? Kellerman didn't smile. I'm planning to keep you alive. He pulled out a piece of paper and sketched a rough diagram. A Sherman tank, viewed from the side, with a grid of wire mesh suspended several inches away from the hull. The mesh would be held in place by welded brackets, creating a cage that surrounded the tank's most vulnerable areas, the sides and rear. When a Panzerfaust hits, Kellerman explained, the warhead uses a shaped charge to focus an explosion into a narrow jet of molten metal. That jet can punch through steel like it's butter. But the jet only works if it detonates at the right distance from the target, usually about 6 inches. Any closer or farther, and the penetration drops off. He tapped the sketch. If we put a screen of wire mesh around the tank, the warhead will hit the mesh first and detonate early. The explosion will still happen, but the jet won't have enough distance to form properly. By the time it reaches the real armor, it'll be dispersed, weakened, maybe even deflected. Briggs leaned closer, squinting at the drawing. You really think that'll work? I think it's worth testing, Kellerman said. What he didn't say was that the idea had come to him years earlier, long before the war, when he'd been troubleshooting a problem at a factory in Detroit. A hydraulic press had been misfiring, spraying high-pressure oil across the workshop. The solution had been simple. A mesh screen placed a few inches in front of the nozzle to disperse the jet before it could cause damage. The principle was the same. Interrupt the energy at the source, and you could stop it from ever reaching its target. Over the next 3 days, Kellerman and his crew worked in near silence. They cut the wire into sections, bent it into frames, and welded the frames onto an abandoned Sherman hull that had been written off as unsalvageable. The mesh covered the tank's sides and rear, spaced roughly 8 inches from the armor, held in place by simple steel brackets. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The result looked absurd. The Sherman, already ungainly, now resembled a rolling birdcage. Some of the men called it the chicken coop, others called it a waste of time, but Kellerman ignored them. He'd done the calculations in his head a dozen times, and every time the math worked. On the 4th day, Lieutenant Collins returned to inspect the work. He circled the tank slowly, his expression unreadable. "This is what you've been building?" he asked. "Yes, sir." "It looks ridiculous." "Yes, sir." Collins sighed. "You know we can't send this into combat without testing it." "I know," Kellerman said. "That's why I need a Panzerfaust." The lieutenant's eyes widened. "You want to shoot at your own tank?" "It's not mine, sir. It's already a write-off. And if this works, it could save every crew in the division." For a long moment, Collins said nothing. Then he turned to one of the MPs standing nearby. "Find me a captured Panzerfaust. I want it here by tomorrow morning." "Yes, sir." The next morning, under a grey drizzle, a small crowd gathered in the muddy field behind the depot. Word had spread that the engineer sergeant was going to test his crazy wire cage, and nobody wanted to miss it. Mechanics, drivers, even a few tank commanders stood in a loose semicircle, arms crossed, waiting. Kellerman stood beside the modified Sherman, his hands shaking slightly despite the cold. In front of him, propped on a wooden stand, was a Panzerfaust captured 2 weeks earlier from a German position near Metz. It was a simple device, a steel tube about 3 feet long, with a bulbous warhead at one end and a primitive trigger mechanism at the other. Lieutenant Collins held the weapon carefully, as if it might explode in his hands. "You sure about this, Sergeant?" Kellerman nodded. "Aim for the side, midway between the tracks and the turret. That's where they usually hit." Collins walked to a position about 30 yards from the tank, the maximum effective range of the Panzerfaust. He knelt, steadied the tube on his shoulder, and looked back at Kellerman one last time. "Fire when ready, sir," Kellerman called. The explosion was immediate and deafening. A streak of flame erupted from the tube, followed by a roar that echoed across the field. The warhead struck the wire mesh with a sharp crack, and for a split second, the entire cage seemed to glow orange. Smoke billowed outward, thick and acrid, obscuring the tank completely. When the smoke cleared, Kellerman ran forward, his heart pounding. The mesh was scorched, twisted in places, but still intact. He reached the hull and ran his hand along the armor. There was a shallow dent, no deeper than his thumb, and a streak of soot, but no puncture, no molten spray, no catastrophic penetration. The warhead had detonated early, just as he'd hoped, and the jet had dispersed before it could focus. Behind him, the crowd was silent. Then, slowly, someone started clapping. Another joined in, then another, until the entire field erupted in applause. Kellerman didn't hear it. He was staring at the dent, his mind already racing ahead. The wire had worked, but barely. The spacing wasn't quite right, and the mesh was too thin in places. If he could refine the design, make it stronger, lighter, more consistent, he could turn this prototype into something the entire army could use. Lieutenant Collins appeared beside him, grinning. "I'll be damned, Sergeant. You actually did it." "Not yet," Kellerman said quietly. "But we're close." That night, he sat alone in the shed, surrounded by sketches and calculations. The war outside continued without pause, artillery rumbling in the distance, flares lighting the horizon. But for the first time in months, Kellerman felt something close to hope. He'd found the answer, not in a laboratory or a research facility, but in a muddy field in France, using nothing more than scrap wire and stubbornness. Now, all he had to do was convince the army to use it. In the autumn of 1944, the war in Europe had entered a brutal new phase. The Allied advance across France had slowed to a grinding crawl as German forces retreated into fortified cities and dense forests. Every street, every village, every crossroads became a killing ground. And in that environment, the M4 Sherman tank, once celebrated as the backbone of American armor, had become a death trap. The Sherman was never meant to fight in cities. It had been designed for open terrain, where its speed and reliability could outmaneuver heavier German tanks. But in the tight confines of urban combat, those advantages disappeared. The tank's thin side armor, adequate against rifles and machine guns, was hopelessly vulnerable to close-range anti-tank weapons, and the Germans had an endless supply of them. The Panzerfaust was the most terrifying. Cheap, disposable, and devastatingly effective, it could be carried by a single soldier and fired from a window, a doorway, or a pile of rubble. The warhead used a shaped charge principle discovered decades earlier by American physicist Charles Monroe, a phenomenon where an explosive, lined with a copper cone, could focus its energy into a high-velocity jet capable of burning through steel, like a blowtorch. When a Panzerfaust struck a Sherman at the optimal standoff distance, the results were catastrophic. The jet would pierce the armor in milliseconds, spraying molten metal and superheated gas into the crew compartment. Ammunition would cook off, fuel would ignite, and the entire tank would become an inferno. Crews rarely had time to escape. Those who did were often maimed by burns or shrapnel. By September, the Third Army's tank battalions were losing vehicles faster than they could be replaced. In one engagement near Metz, an entire company of Shermans was knocked out in less than an hour. The after-action report described it as a systematic execution, German soldiers methodically targeting each tank from concealed positions. then disappearing into the rubble before infantry could respond. The tankers themselves developed a dark fatalism. They painted names on their hulls, not out of pride but as memorials, knowing that the machine would likely outlive its crew. Some men refused to close the hatches, preferring the risk of small arms fire to being trapped inside a burning steel coffin. Others simply stopped caring, driving into combat with the numb detachment of men who had already accepted their deaths. In Washington, the Ordnance Department was aware of the problem, but paralyzed by bureaucracy. Engineers at Aberdeen Proving Ground had tested dozens of solutions: applique armor plates, sandbag shields, even concrete layered onto the hull, but every option added weight that the Sherman's suspension couldn't handle. The tank would bog down in mud, throw tracks, or simply break apart under the strain. Meanwhile, field commanders grew increasingly desperate. Some units welded spare track links onto their tanks, creating crude armor that added minimal protection but significant weight. Others wrapped sandbags around the hull, a psychological comfort that did almost nothing to stop a shaped charge. A few enterprising crews even tried mounting logs or wooden planks as standoff shields, but these caught fire easily and obstructed visibility. The official stance from the War Department was that the Sherman was adequate for its role and that losses were within acceptable parameters. But the men who climbed into those tanks every morning knew better. They were being sent into urban meat grinders in machines that had been obsolete the moment the Germans developed the Panzerfaust. David Kellerman understood this better than most. As a field maintenance engineer, he saw the wreckage up close, the punctured hulls, the charred interiors, the scattered personal effects of men who had died inside. He read the casualty reports and listened to the survivors describe the moment of impact, the sound like a hammer striking an anvil, the flash of orange light, the screams. But what haunted him most was the waste. Every destroyed Sherman represented not just 5 dead Americans, but also a failure of engineering. The Army had spent billions of dollars developing tanks, yet it had overlooked the simplest question of all. How do you protect a machine when the enemy's weapon costs $10 and can kill it in one shot? The answer, Kellerman believed, was not to make the armor thicker. It was to change where the explosion happened. He'd spent years studying industrial safety, designing systems to prevent catastrophic failures in factories and refineries. The principle was always the same. You couldn't always stop an accident, but you could control where and how it occurred. A pressure vessel might be designed to rupture in a safe direction. A chemical reaction could be contained by introducing a buffer material. The key was to intercept the energy before it reached the vulnerable point. The shaped charge worked because it concentrated explosive force into a narrow jet, but that jet required a precise standoff distance to form correctly. Too close, and the explosion would dissipate before the jet could penetrate. Too far, and the jet would lose coherence and energy. The optimal distance for a Panzerfaust was about 6 inches from the target surface. If Kellerman could create a barrier that forced the warhead to detonate further away, the jet would strike the actual armor in a weakened, dispersed state. The tank might still be damaged, but the crew would survive. The idea of using wire mesh had come to him almost by accident. He'd been walking through the ruins of a bombed-out factory in Nancy when he noticed the remains of a chain-link fence still standing amid the rubble. The fence had been struck by shrapnel, its wires twisted and scorched, but still intact. Something about the way the metal had absorbed and dispersed, the impact stuck in his mind. That night, he'd sketched the concept in his notebook: a cage of wire mesh suspended several inches from the tank's hull, light enough to be fabricated from scrap, simple enough to be installed by any maintenance crew. It wasn't elegant, and it certainly wasn't official, but it might work. The test firing the next morning proved the concept, but Kellerman knew that one successful trial meant nothing to the Army. He needed data, multiple tests, different angles, different ranges. He needed to prove that the design could withstand repeated hits and still protect the crew inside. Over the next week, he conducted 6 more tests, firing captured Panzerfausts at the modified Sherman from various positions. Each time, the wire mesh absorbed the initial blast, forcing the warhead to detonate prematurely. The explosions were violent, tearing holes in the mesh and bending the support brackets, but the hull armor remained intact. In every case, the penetration was reduced to a shallow dent or a superficial gouge. The mechanics who had mocked the chicken coop now watched in silence. Some began taking notes. Others started measuring the wire spacing and frame dimensions, already thinking about how they could replicate the design on their own tanks. Lieutenant Collins filed a report with division headquarters, describing the tests and recommending immediate adoption of the wire mesh shields. The response was swift and discouraging. The Ordnance Department rejected the proposal, citing lack of standardized testing, concerns about weight distribution, and the absence of official authorization. Kellerman read the rejection letter twice, then crumpled it into a ball and threw it across the shed. He'd spent a week proving that his design worked, and the bureaucrats in Washington had dismissed it with a form letter. But the tank crews themselves didn't care about official authorization. Word of the successful tests spread through the division like wildfire. Within days, commanders from other battalions were visiting the depot, asking to see the modified Sherman. Some brought their own maintenance sergeants, who sketched the design and took measurements. Others simply asked Kellerman to build more. He worked through the nights, welding frames and cutting mesh, training other crews on how to install the shields. The supply sergeant, Kowalski, scrounged wire from every bombed-out building and abandoned rail yard in eastern France. Soon, dozens of Shermans were rolling out of field depots with improvised cages welded to their hulls. The tankers called it hillbilly armor, a term that was equal parts mockery and pride. It was ugly, unorthodox, and completely unauthorized, but it worked. And in a war where survival often came down to luck and ingenuity, that was all that mattered. By late September, the Third Army's tank losses in urban combat had dropped by nearly 40%. Crews reported multiple instances where Panzerfaust struck the wire mesh and failed to penetrate the hull. One Sherman took 3 hits in a single engagement and kept fighting, its crew shaken but alive. The official reports from division headquarters made no mention of wire mesh shields. Instead, they attributed the improved survival rates to better tactics and increased infantry support. But the men who fought in those tanks knew the truth. David Kellerman, a 32-year-old engineer from Ohio who had never fired a shot in combat, had saved more lives than any general or strategist. And he'd done it not with advanced technology or billion-dollar research programs, but with scrap wire and a refusal to accept that good men should die in bad machines. The morning of October 14th, 1944, dawned cold and grey over the forests east of Nancy. The 3rd Armoured Division's task force had been ordered to clear a series of German strongpoints along the Moselle River, a grinding operation that promised heavy casualties. Among the lead tanks was a Sherman commanded by Staff Sergeant Ray Mitchell, a 24-year-old from Pennsylvania, who had survived 3 previous engagements and considered himself lucky to still be breathing. Mitchell's tank, nicknamed Lucky 7, had been fitted with Kellerman's wire mesh cage 4 days earlier. The installation had taken less than 6 hours, and Mitchell had been skeptical at first. The cage added about 300 pounds to the tank's weight, not enough to affect performance, but enough to make it look like something cobbled together in a junkyard. "We look like a goddamn circus wagon," his gunner, Corporal Hastings, had joked. But Mitchell had heard the stories from other crews. Tanks with the mesh were coming back. Tanks without it weren't. That was enough for him. At 06:30, the column rolled out, 12 Shermans followed by a company of infantry in half-tracks. The forest was dense, the road narrow, visibility reduced to less than 50 yards. Every tree, every shadow could hide a Panzerfaust team. The radios crackled with terse commands as the column advanced slowly, turrets traversing left and right, scanning for threats. Mitchell sat in the commander's cupola, his stomach tight, with the familiar pre-combat tension. The smell of diesel exhaust mixed with the damp scent of pine and wet earth. His loader, a kid from Iowa named Daniels, was quietly singing under his breath, a nervous habit that drove everyone crazy but nobody had the heart to stop. At 07:15, The lead tank reported movement ahead. Seconds later, the forest erupted in gunfire. Rifle rounds pinged off the Sherman's armor like hail on a tin roof. Mitchell ducked instinctively, scanning the tree line through his periscope. "Contact left!" Hastings shouted. "Infantry in the trees!" The turret swung, the 75mm gun barking twice. High explosive shells tore through the undergrowth, splintering trees and sending up geysers of dirt. The infantry dismounted from their half-tracks and began returning fire, their BARs and M1s adding to the chaos. Then came the sound Mitchell had been dreading. A sharp, hollow pop from somewhere off to the right, followed by the distinctive whoosh of a rocket motor. "Panzerfaust!" someone screamed over the radio. The warhead struck Lucky 7 on the right side, just behind the turret. The explosion was instantaneous, a flash of orange flame and a concussive blast that rocked the tank sideways. Mitchell's ears rang, his vision blurred by smoke and dust pouring through the open hatch. For a horrible second, he thought they were dead, that the shaped charge had punched through, that the interior was already filling with fire. But then Daniels shouted, "We're okay! We're okay!" Mitchell blinked, his hearing slowly returning. The tank was still running, the engine purring steadily beneath him. He looked down through the hatch and saw no flames, no molten spray, just smoke and the acrid smell of burnt metal. "Driver, back us up!" he yelled. "Get us behind that ridge!" The Sherman lurched backward, tracks churning through the mud. Another Panzerfaust streaked past, missing by inches. Mitchell dropped into the turret, slammed the hatch shut, his heart hammering against his ribs. "Hastings, can you see where they're shooting from?" "All units, fall back to Rally Point Alpha. We're taking fire from multiple positions." The column retreated in controlled chaos, tanks reversing through the trees while infantry provided suppressing fire. By the time they reached the rally point, a small clearing half a mile back, Mitchell's hands were shaking so badly he could barely hold the radio handset. He climbed out of the turret and jumped down to inspect the damage. The wire mesh cage on the right side was twisted and scorched. Several of the welds had cracked, and the mesh itself had a gaping hole where the warhead had struck. But beneath it, the hull armor was barely scratched. A shallow gouge, maybe a quarter-inch deep, and some heat discoloration. Nothing that would prevent the tank from fighting. Hastings climbed out after him, his face pale. "Jesus Christ, Sarge, that should have killed us." Mitchell stared at the wire cage, his mind struggling to process what he was seeing. The Panzerfaust had hit them dead on, at point-blank range, in exactly the kind of ambush that usually meant a total loss. But the mesh had worked. The warhead had detonated early, and the jet had dispersed before it could penetrate. "Get Kellerman on the radio," Mitchell said quietly. "Tell him his chicken coop just saved 5 lives." By nightfall, word of the engagement had reached every unit in the division. Mitchell's crew became minor celebrities, invited to other companies to describe exactly what had happened. Other tank commanders inspected the damage to Lucky 7, running their hands over the twisted mesh and the shallow gouge in the armor. One captain, a skeptic who had refused to install the mesh on his own tanks, simply shook his head and said, "I'll have mine done by tomorrow morning." Within a week, nearly every operational Sherman in the Third Army had been fitted with wire mesh shields. The depot at Nancy became a round-the-clock factory, with welders working in shifts to fabricate cages from whatever material they could find. Some used chain-link fencing, others used rebar or heavy-gauge electrical cable. The designs varied wildly, but the principle remained the same: create a standoff barrier that would detonate the warhead prematurely. The German reaction was swift and confused. Intelligence reports from captured prisoners described frustration among Panzerfaust teams who had scored direct hits only to see the tanks keep fighting. Some believed the Americans had developed new armor. Others thought the mesh was somehow deflecting the warheads, a misunderstanding that led to frantic discussions among German engineers about how to counter the unexpected defense. In truth, the Germans had no immediate answer. The Panzerfaust's design was fixed, its standoff distance optimized for bare metal. Adding more, Explosive would make the weapon too heavy to carry. Increasing the penetration depth would require a complete redesign, something the collapsing German war economy couldn't afford. For the American tank crews, the psychological impact was profound. Men who had accepted death as a near certainty now felt a flicker of hope. They still respected the Panzerfaust, but it was no longer an automatic death sentence. Some crews even began taking risks they wouldn't have dared before, pushing deeper into urban areas, engaging targets at closer ranges. The survival statistics told the story. In September, before the widespread adoption of mesh shields, the Third Army's tank loss rate in urban combat had been approximately 7% per engagement. By November, with most tanks fitted with the improvised armor, the rate had dropped to less than 3%. Over the course of 2 months, hundreds of lives were saved. David Kellerman watched the transformation from the depot at Nancy, where he continued to supervise the fabrication of new shields. He received no official recognition, no medals, no promotion. The Ordnance Department still refused to acknowledge his design, maintaining that the mesh cages were unauthorized field modifications that violated Army regulations. But Kellerman didn't care about regulations. Every night, he walked through the rows of tanks waiting for repairs, running his hand along the wire cages, counting the scorch marks and impact craters. Each mark represented a crew that had gone home instead of into a body bag. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. One evening in late October, Staff Sergeant Mitchell found Kellerman in the welding shed, bent over a workbench covered in sketches and calculations. Mitchell held out a bottle of liberated French wine. "Thought you might want this," Mitchell said. Kellerman looked up, surprised. "What's the occasion?" "No occasion. Just wanted to say thanks. For Lucky 7. For my crew." He set the bottle down on the bench. "You saved our lives, Sergeant. Figured that was worth a drink." Kellerman nodded slowly. "But I wouldn't have known how." Mitchell turned to leave, then paused. "The Army's going to figure out eventually that you're right. When they do, every tank in Europe's going to have one of those cages. And a lot of men are going to come home because of it." After Mitchell left, Kellerman sat alone in the quiet shed, the bottle of wine unopened beside him. Through the open door, he could see the silhouettes of tanks lined up in the darkness, their wire cages casting strange shadows in the moonlight. He thought about the hundreds of crews he'd never meet, men who would survive because of a simple idea born in a moment of desperation. He thought about the engineering elegance of it, how something so crude could defeat, something so sophisticated. And he thought about the morning in Nancy when he'd stood beside those 4 burned-out Shermans and refused to accept that good men should die for want of a solution. The war would go on for many more months. The fighting would grow worse before it ended. But in that moment, sitting in a drafty shed in eastern France, David Kellerman allowed himself to believe that he'd made a difference. Not with grand strategies or advanced weapons, but with scrap wire and the stubborn conviction that every life was worth saving. By December 1944, the wire mesh shields had become so ubiquitous that new crews arriving from the replacement depots assumed they were standard issue. The cages were welded onto Shermans at maintenance facilities from Normandy to the German border, each one unique in its construction, but identical in purpose. The Army still refused to officially adopt the design, but field commanders no longer cared about authorization. They cared about bringing their men home alive. The Battle of the Bulge, Hitler's desperate winter offensive through the Ardennes forest, would test the improvised armor under the worst possible conditions. In the confusion of that savage campaign, American tank units found themselves fighting in close terrain against German forces, armed with Panzerfausts, Panzerschrecks, and every other anti-tank weapon the Wehrmacht could muster. Among the units caught in the initial assault was the 7th Armoured Division, tasked with holding the town of Street, with against overwhelming German forces. Their Shermans, nearly all equipped with mesh shields, fought a desperate delaying action that bought time for the American line to stabilize. One after-action report, filed in January 1945, noted that tanks with wire mesh protection sustained an average of 2.3 Panzerfaust hits per vehicle during the engagement, compared to immediate destruction for unprotected tanks. The report concluded that the field modification had prevented the loss of at least 40 vehicles and 200 men during the first 3 days of fighting. The German response evolved slowly. By early 1945, Panzerfaust operators were being instructed to aim for vision ports, track assemblies, and other vulnerable points rather than the now protected hull sides. Some units began using multiple warheads in quick succession, hoping to overwhelm the mesh shields through sheer volume of fire. But these adaptations came too late. Germany's industrial capacity was collapsing, ammunition was scarce, and trained personnel were in short supply. Meanwhile, the American military bureaucracy finally began to take notice. In February 1945, the Ordnance Department dispatched a team of engineers to Europe to study the field modifications and assess their effectiveness. The team's report, submitted in March, acknowledged that the improvised mesh shields provided significant protection against shaped charge weapons and recommended formal adoption of a standardized design. By then, the war was nearly over. Germany would surrender in May, and the Sherman tank would soon be relegated to training units and surplus sales. The official adoption of wire mesh armor came too late to matter in combat, but the principle had been proven. Future tank designs would incorporate standoff protection as a standard feature, from the reactive armor tiles on Cold War-era vehicles to the cage armor used on modern armored personnel carriers in Iraq and Afghanistan. David Kellerman's contribution would be documented in a footnote of a technical report filed in June 1945. The report, titled Field Modifications to M4 Medium Tank Armor Protection, credited an unnamed maintenance engineer with developing the wire mesh concept and noted that similar designs had been independently adopted by multiple portable units across the European theatre. Kellerman himself was discharged in August 1945 and returned to Toledo, where he resumed his work as an industrial engineer. He never spoke publicly about his wartime invention, never sought recognition, never contacted the military to claim credit. To him, the work had been its own reward, a problem that needed solving, solved as efficiently as possible. In 1958, a military historian researching tank warfare came across references to the wire mesh shields in archived after-action reports. Intrigued, he tracked down several veterans who had served in units that used the improvised armor. Each one described it as life-saving. Each one attributed it to anonymous mechanics and welders working in field depots. None could remember a specific name. The historian eventually found Lieutenant Collins, by then a retired colonel living in Virginia. Collins remembered Kellerman clearly and provided a detailed account of the initial tests at Nancy. The historian attempted to contact Kellerman for an interview, but discovered that he had died 2 years earlier from a heart attack at age 46. The story appeared as a brief article in a specialized military journal, read by perhaps a few hundred people, then forgotten. No monument was erected, no medal awarded posthumously, no textbook carried his name. The wire mesh shields themselves were mostly scrapped after the war, melted down along with the tanks they had protected. But the principle survived. Every modern armored vehicle that rolls off an assembly line today carries some form of standoff protection, some descendant of that first crude cage welded together in a muddy French depot. The engineers who design those systems work in climate-controlled laboratories with advanced computer simulations and million-dollar testing facilities. Few of them know that their work traces back to a Toledo engineer who mixed desperation with ingenuity and changed the odds for thousands of men he would never meet. In the archives of the National World War II Museum in New Orleans, there is a single photograph of a Sherman tank fitted with wire mesh shields. The image is grainy, dated December 1944, location unknown. The tank's crew stands beside it, 5 young men squinting into the winter sun, their faces impossible to distinguish at this resolution. Someone has written a caption on the back of the photo in faded pencil. Our chicken coop. Took 3 hits at Street Vith. Everyone made it home. The handwriting is careful, deliberate, The words of someone who wanted to remember. That photograph, like the story it represents, sits in a filing cabinet in a climate-controlled basement, rarely viewed, almost never discussed. But it remains there nonetheless, a testament to the idea that wars are won not only by generals and grand strategies, but by ordinary people who refuse to accept that the way things are is the way they must be. David Kellerman understood this instinctively. He saw a problem that was killing men, and he solved it with the tools at hand. He didn't wait for permission or authorization or official approval. He simply acted, because acting was better than watching good people die. In the end, that may be the truest form of heroism, not the loud and celebrated kind, but the quiet refusal to let tragedy become routine. The conviction that every life matters, that every problem has a solution, and that sometimes the most important thing you can do is weld together some scrap wire and hope it's enough. For the crews of the 3rd Armoured Division, for Staff Sergeant Mitchell and the men of Lucky 7, for hundreds of others whose names have faded into history, it was more than enough. It was the difference between coming home and never coming home at all. And in the mathematics of war, where survival is measured in fractions of inches and milliseconds of delay, that difference is everything. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.